We have a November 2015 exam paper. Question 4. A bullet of mass 20 grams is fired from a stationary rifle of mass 3 kgs. Assume that the bullet moves horizontally. Immediately after firing, the rifle recoils, moves back with a velocity of 1.4 meters per second. So within this question we have two objects. We have the bullet and we have the rifle. Now we'll refer to the bullet as object A and the rifle as object B. Our first question is 4.1. Calculate the speed at which the bullet leaves the rifle. Now, before we attempt this question, let's highlight the important values. I'll highlight all the bullet related values in red and all the rifle related values in purple so that we can differentiate between the two. Now keep in mind the mass of the bullet is not in its SI unit. It is in grams. It's supposed to be converted to kgs. In order to go from grams to kgs, we divide by 1,000. Then it states the rifle is stationary. If the rifle is stationary, it means that it has a velocity of 0. It also has a mass of 3 kgs. It then states immediately after firing. So now we are referring to the final values. Why? Because keep in mind, before the collision is your initial quantities or initial values, and after the collision are your final values. So immediately after firing, the rifle recoils. So to recoil is to move backwards. So that means that the final velocity of this rifle is negative if we assume the forward direction to be positive. So because the rifle recoils after it was fired, or after the bullet was fired, it recoils, it moves backwards, it moves in the opposite direction to its initial direction. Its final velocity should be negative. So this 1.4 will be negative. It is moving in the opposite direction to the initial direction. Now, we need to calculate the speed of the bullet after it leaves the rifle. So we need to find the final velocity of this bullet. Keep in mind we are referring to the bullet as object A. Now, let's start. Before we start, let us assume a positive direction. So we are going to assume right as positive. You can also assume forward as positive because they refer to forward and back. And if you look at this picture, you can see that the rifle, or rather the bullet, is moving to the right. So that is why I stated right as positive. Now, before we get started with our question, let's state a few important values. But first of all, take note that the bullet is A and the rifle is B. So the mass of A was 20 grams, and if we put that into our calculator, 20 divided by 1,000, that gives me 0.02. Take note that you have to divide by 1,000. We then know that the mass of the rifle is 3 kgs. The initial velocities of both the rifle and the bullet are 0. Because if we go back to our question, it stated that the rifle was initially stationary, and we know that the bullet will be inside of the rifle before it is fired. So if the rifle is stationary, it means the bullet is stationary. Another way of thinking about this is if you are sitting in a parked car. If the car is parked, it means it's stationary. It has a velocity of 0. Therefore, you will also have a velocity of 0 because you are inside of the car. It's the same situation with the bullet and the rifle. Because the rifle was initially stationary, meaning it had a velocity of 0, and the bullet is inside of the rifle before it is fired, that means that the bullet will also have an initial velocity of 0. And we needed to find the final velocity of this bullet. And keep in mind, the rifle recoils, so it moves backwards with a velocity of 1.4 meters per second. So because it is moving in the opposite direction that we are assuming as positive, it's moving backwards, or you could say moving to the left, that 1.4 is going to be negative. So here we can say that the final velocity of B is a negative 1.4 meters per second. It's important to assume a positive and negative direction, because if you do not put the correct signs into your equation, then you will not produce a correct answer. Your answer will be incorrect. So from here, we now have all of the known and unknown quantities. Our only job is to write down our equation and substitute. So we are going to use our conservation of linear momentum equation. We are going to have the momentum of all of the initial the initial momentum of both objects is equal to the final momentum of both objects. So here we have the sum of the initial momentum is equal to the sum of the final momentum. Keep in mind this is of object A and B. So we can break it up as the mass of object A times the initial velocity of object A plus the mass of object B times the initial velocity of object B. And that is equal to the sum of the final momentums, which is mass of A times final velocity of A plus the mass of B times the final velocity of B. Now, let us start to substitute. So we can substitute 0.02 times 0 plus 3 times 0 is equal to 0.02 VFA plus 3 times negative 1.4. From here, the entire left hand side is going to be 0, and this will remain 0.02 times the final velocity minus, so we put 3 times negative 1.4 on our calculator. That gives me negative 4.2. Now we can take this 4.2 to the left, making it positive 4.2. From here we divide by our coefficient, so 4.2 divided by 0.02, and that gives me 210. Keep in mind we have a positive value. That means that the bullet is moving in the positive direction, or you could say forward, or you could say right. So this is the velocity of our bullet after it was fired from the rifle. Now, let us attempt question 4.2. Now, question 4.2 states, the bullet strikes a stationary 5 kg wooden block fixed to a flat horizontal table. The bullet is brought to rest after traveling a distance of 0.4 meters into the block. Refer to the diagram below. So what's happening is we have two objects, that's the bullet and a block. Now keep in mind the block is fixed to the table or fixed to the floor. They specified table, yeah. So the block is fixed to this table, right? Meaning it's not going anywhere. So this block stays fixed on this table and the bullet enters the block, travels a certain distance through the block and then exits that block. So we are still going to refer to the bullet as object A and we can refer to the block as object B. Now question 4.2 states, calculate the magnitude of the average force exerted by the block on the bullet. So we need to calculate the force that the bullet exerts, or rather that the block exerts onto the bullet. Now keep in mind the force that the bullet will exert onto the block is the same force that the block will exert onto the bullet because of Newton's third law. Okay, so let us read this paragraph and highlight the important values. So we'll use green for B this time so we don't confuse it with the rifle values. So let's start. It states that a bullet strikes a stationary 5 kg wooden block. So this wooden block is stationary and it has a mass of 5 kgs. Keep in mind that because this block is fixed to the table, its initial velocity is going to be 0 and its final velocity is going to be 0. The bullet is brought to rest. So now it states that our bullet is brought to rest, meaning it actually gets stuck inside of this block. It doesn't exit the block. So my previous statement where I stated that it enters the block and then travels a certain distance and exits the block was actually incorrect. This bullet enters the block, travels a certain distance and then gets stuck inside of this block. So our final velocity of our bullet is 0. Our initial velocity of this bullet is the velocity that it left the rifle with, because that is the same velocity that it enters the block with. So it's that 210 meters per second that we calculated in question 4.1. It then states that after traveling a distance of 0.4 meters into the block, so that is our displacement of our bullet. So after traveling a distance of 0.4 meters, this bullet gets stuck inside of the block. So that is why it's very important to read the question a few times so that you can strengthen your understanding of what's going on. Reading it only once won't really help you that much, because as you saw with what happened with me, I forgot a bit of the information after only reading it once. It is where I read it the second time that I started to remember more of the question itself. So the important things to take away from this is that we have a 20-gram bullet that exits a rifle at a velocity of 210 meters per second, that being its initial velocity. This bullet enters a fixed block. Keep in mind the block has a mass of 5 kgs and is initially stationary. Now, after this bullet enters the block, it travels for a distance of 0.4 meters before it becomes stuck inside of the block, whereby the velocity of the block is 0 because it is fixed, and now the velocity of the bullet is also 0 because it got stuck inside of the block. So Let us attempt the question. We need to calculate the force that this block exerts onto the bullet, which will be the same force that the bullet is exerting onto the block. Now, if we want to calculate a force, how do we do that? We know that force is equal to mass times acceleration. However, we do not have the acceleration of this bullet. You can refer to it as the deceleration of the bullet if you want to, because we know that the speed has to decrease in order for it to come to rest. So it's deceleration, or the bullet is decelerating. Okay, or you could say that it would have a negative acceleration because it eventually comes to rest. The velocity decreases. Now, we need to find the acceleration of this bullet. How do we do that? We can use our equations of motion. Now, which equation of motion can we use? Let's make a list of them. We have Vf equals Vi plus A delta t. We have Vf squared equals Vi squared plus 2A delta x. We have delta x equals Vi plus A, no, it's not A. Let's just erase this. So it's delta x equals Vi times delta t plus 1 over 2A delta t squared. And lastly, we have displacement equals a half into Vi plus Vf times delta t. Now, which is the best formula to use? In order to identify which formula we can use, we need to eliminate what we cannot use. Something to take note of is that we do not have change in time. We do not have the time it takes the bullet to enter the block and travel that 0.4 meters. So any formula that does not have, or rather any formula that has time in it, can be eliminated. So first, the third, and the last formula, meaning that we will now use the second formula. On a side note, if you want to use formulas 1, 3, and 4, you can use formula 4 to calculate time, take that time value, and then calculate acceleration. An alternative approach would be to use formula 4 or formula 1 or formula 3 and calculate change in time. Once you calculate change in time, you can then use your impulse formula, which is Fnet times delta t equals impulse. So if you want to use the impulse formula, I would recommend calculating change in time instead of calculating acceleration. However, if you want to use F equals ma, you can calculate acceleration using the second formula. Now, let us make a note of all of the known values, and then we will try to calculate the average force. So let's make a note that we are trying to calculate F net. Now, from here, we know that the mass of the bullet is 0.02 kgs. So keep in mind, we can just copy this instead of having to rewrite all of that information, and just change what we need to, since we now know that the initial velocity of this bullet will be 210 meters per second. Final velocity will be 0 meters per second. We are referring to object B as the block. So the mass of the block is 5 kgs. We know that the initial velocity of the block is equal to the final velocity of the block, which is 0 meters per second. In addition to that, we know that the bullet traveled a displacement of 0,4 meters into the block. So using this information, all we now need to do is substitute into the formula. So we know the initial velocity, or rather the final velocity of this bullet, was 0 meters per second. The initial velocity of the bullet was 210 meters per second. The acceleration is unknown, and the displacement is 0.4 meters. From here, we can square 210, and that gives us 44,100. I'm then going to move that to the left, making it negative 44,100, and that is equal to 0,8 A. From here, we can divide both sides by 0.8, and we therefore have our acceleration as equal to negative 55,125 meters per second squared. Now, from here, we can use our formula F equals ma. Our force is what we are trying to calculate. The mass of this bullet is 0.02, and our acceleration is negative 55,125. We can put that into our calculator, and we therefore have our force as equal to 1,102,5 newtons. Now, let's see. Were we supposed to write down the magnitude only? Let's see. So, question 4.2 states, calculate the magnitude. So, this word is important. We need to calculate the magnitude of the force. So, if we are asked to calculate magnitude, we do not need to include the direction. So we do not need to include the negative sign, okay? So when we put this into our calculator, you should have got a negative value. So if you are asked to write down the magnitude, all you need to do is conclude and ignore the negative sign. That is the magnitude only. So you just ignore the negative sign, because the negative sign indicates a direction. Now, let us have a look at question 4.3. Question 4.3 states, how does the magnitude of the force calculated in 4.2 compare to the magnitude of the force exerted by the bullet on the block? Write down larger than, smaller than, or the same. So keep in mind, according to Newton's third law of motion, if object A exerts a force onto object B will exert an equal force onto object A. So that means with the force that the bullet exerts onto the block is the same force that the block exerts onto the bullet. It's just in a different direction. Therefore, it is going to be the same. So for question 4.3, all we are going to do is write the same.